We're going to learn about Unreal's newer state tree system. This is how you can build a state machine type of setup inside of your games. And by the end of it, we'll have a few platforms that we can customize. You can see they go down, they go up, and you can see the state changing as we jump up and down off of it, and each one can work or be deactivated. And to show you a little bit of what we're going to end up with, we'll have some state tasks, which will be modular, meaning we can reuse them. And we'll have our weighted platform schema, which we can isolate out into child states. We'll have enter conditions, we'll have debug text, we'll have delays, we'll have particles, audio. All of this will be reusable. And by the end, you should understand how it is put together and how to make your own. So with all of that out of the way, let's get started. So the state pattern is a programming pattern that lets us break down logic into smaller pieces to give an object more complex behavior. If you were just to program a drone unit, just open a blueprint and start typing, that might be very complicated, right? You could have a lot of edge case scenarios and it would be impossible to debug. But if you can break up their behavior into different isolated states and then just transition between them based on conditions, more complex behavior can be implemented more simply. So for example, trying to find a node is just moving from point A to point B, then waiting, then returning back to the drop-off point. These three different states, that is more isolated behavior. And once you put that system together, you could start building off of that more easily rather than just having a giant branching list of possibilities inside of a blueprint. So we want to use state trees to define our behavior in modular blocks that we can then transition between based on different conditions. And that will give us the ability to expand as much as we want. Once you're inside, we need to enable the plugins. For me, I still need to enable these in order to use state tree, but maybe they come automatic in the future. I'm going to search for state tree, and the two that I want are gameplay state tree and state tree. Okay, so mine are already enabled, so that's good. We'll exit out. Next, I'm going to make my weighted platform actor. So I'm going to come into my content browser. Let's make a new folder for this. We'll call this gameplay. And underneath that, I'm going to make my mechanic, which will be, actually, let's make a folder called weighted platform. And inside of that folder, let's make a new blueprint class, and actor. This will be our weighted platform blueprint. BP _ weighted platform. Control S to save. And let's just set this up real quick. But I want to set up something that we can use for prototyping for now. Add a cube. Since we're using a cube, we do have to mess with the transforms on this. But if you replace this with a mesh later, just make sure to zero out everything up here. So to stretch this out, I'm going to do 2 scale 2 and then 0.1. We're looking for a flat platform that we can stand on top of. And then I also want a box collision. So I'm going to click to deselect. I want to keep my default scene root. Search for box collision. We can keep the name, compile, save. And we want our box collision to align with the top of the actor right here. I like to do this with the box extent. Technically, you could scale it, but I think this is a little bit more proper, and it's good to see both anyways. So for box extent, this is going to be 100, and you could just, stretch this out as you want to fit, but the exact is going to be 100, 105. And that fits in the platform, but I also want to pull it up 1 notch right there. So that's about 10 upwards. So this box collision should sit right on top of the platform. Now what we're going to do is we're going to use this box collision to detect if something is on top of the platform, right? We don't want it to sync if we're touching the actor because it could be touching the bottom or the sides. So if they are inside of this box collision, we'll send some kind of trigger that the platform should sync. But that's going to be our setup. Let's compile, save, and let's actually put this in the scene too. Let's come over here. We'll drag one in the scene. We just want it to be kind of near this this platform so we can walk onto it. Something like that. Now our platform's going to pass through geometry. You could make this more complex and different later on. Next, in order to get the state tree system working, we need to set up our assets correctly. So what we need is we need our weighted platform, and this is going to be the actor that will use the state tree system. And then we're going to attach a component on this actor called a state tree component. So on your actor, open it up. If you add a component called state tree, right, not AI, since this is just a generic gameplay thing, not a AI that will run around, so state tree, this component gives this actor the capability of using the state tree system. The problem is we need an asset that defines all the states and how the system will run. So inside of the component, we need to create an asset and then plug it into this thing right here, this AI state tree. So let's do that. Now that we have the component added, let's stay inside of our weighted platform folder, right click. For me, under gameplay, you're going to see state tree. And we have two options. The first one is a generic state tree component. This could be on anything related to gameplay. And then the second one is AI. So it's going to give you more complex stuff. We're going to choose the first one since this is not an AI. The naming convention will be ST for state tree underscore whatever the thing is. We'll call this weighted platform. Control S to save. And this is our asset that we're going to customize to define our state tree logic. But we need to plug this asset into the component on our actor. So open our actor back up and find the component. And inside of here, underneath AI, we're going to look for the state tree for ST underscore weighted platform. All right, so now our actor component is looking at this state tree that we'll customize for all of its logic. So compile and save. Let's get out of there. We can open up the state tree. So just double click under context. This is going to be the owning actor that we can send down into all of our states. And we want this to be specific to our blueprint. So we want it to be our BP underscore weighted platform. This is because if we put variables or any other kinds of things on our blueprint weighted platform, we can get access to them inside of the states. And we're going to want to do that at some point. So if you expand schema under context actor class, we don't want the generic actor. I mean, we could if we were making something very, very generic, but I actually want the BP underscore weighted platform. This will allow us access to variables and things on side of our blueprint. We'll keep the scheduled tick policy right here, but this is something you could mess with for optimization later. If we hit compile, save, you should see now our context. So anytime you see the word context, which we'll use later on, it is referencing this blueprint weighted platform, which is very cool because then we get access to all of the blueprint weighted platform type things, which will come in handy. Next, we want to think about what are the different states that our actor might need. I might want an idle state. So this is when we're just waiting for an actor to get on the platform. Right, so we're just waiting at the top for something to happen. It's usually good to have some kind of state where you're doing nothing. Then with our weighted platform, we probably want a sinking state where we are slowly falling as long as the actor is on it. And then we will want a rising state. This is when we're rising back up to the starting position if no actor is on it. And we're just starting with these three states for now. We'll expand it. We'll add some edge cases. We'll add some additional states and so forth. But it's usually good to start simple. So in order to add these states, it's usually good to start from the root. And what I'm going to do is just click the root and you can click add state. I'm going to undo that just to show you. You could also just right click, get add state, and you could add a sibling state, which is side to side, or you can add a child state, which is underneath. So I'm going to make these child states of the root. That way I can always return back up to the root and then we can flow down our states as we need. So I made one, we'll call this idle. Let's make another one. Right, you could either make a child state like this, or you could select the child state and just Control D to duplicate it. And we want our sinking state, sinking, and I'm going to leave out the word state since it's pretty obvious, and then rising. So we have our three states right here. Let's compile and save. But what would be nice is if we could see what state we're in when we're playing the game. So right now, if we hit play, nothing's really going to happen. Our state system is set up on it, but it's just a platform that doesn't do anything. So let's print some debug text so that we can see what state we're in. It's a pretty common task to run. A task is how we can run behavior inside of a state. So for example, while we're in idle state, if you look over here on the right, you're going to see a lot of things here. You'll see inner conditions, which we'll get to, ways to select different states with waiting. That's the selection utility. Or tasks. Tasks is what we want. So hit the plus button. And these are some pre-built tasks that we have available to us before we even, define our own. For example, debug and delay we'll be using quite a bit. But for now, debug text task. So if we click that, we are adding a task that will run while we're inside of the idle state. So for our debug text, let's just put the name of the state. So we'll just say idle. And you can also see some parameters down here. If we wanted to change the text color, we could. I'm not going to mess with that. What I do want to change is this reference actor in. When it's default, it's just going to print at the world origin. I don't want that. I want the text to actually follow the actor around as it moves. So I want to click this little arrow, and this will allow us to change the reference for this variable. We'll do this more later. We want to choose actor at the bottom. Now this is actually pointing to the actor context if we select it like that, meaning the owner of this state tree, which gets linked into the component. So it would be the BP weighted platform, right? That's going to be the owner. So we're going to print this text on the context, which remember is the owner of the state tree. Okay, let's compile, save. Let's do the same thing for syncing and rising. You can even see that it updates our little tree, which lets us view things very quickly and very easily. So click on syncing, go to task. We're going to add another task while we sync. So add debug text task, kind of hard to say. We'll call this syncing. And again, we want the reference actor in. Click the little drop down and say we want this actor, this specific one. We just named it actor. Okay, compile, save, and we'll add one more. For rising, do task, debug, call this rising. And then the reference actor, again, you want to choose our actor, so our actor context. So yeah, you could customize this more, but for now, let's compile and save. And I want to show you something. Right now we have our 3 separate states, but we're really just going to hit the first state idle, and we're just going to stay here. So I want to show you that. Play. So you should see the text hovering over our actor, which that is good. But the problem is we're never going to syncing or rising. So I'm going to use this opportunity to talk about transitions. While we're in idle, we want to wait for something, in this case, someone to step inside of our box collision. We'll do that later. For now, we're just going to set this up to test. When we're in idle, we want to transition to syncing. So for now, I'm just going to do this with a delay. I'm going to wait in idle. We're going to wait for 1 second, then we're going to go to syncing, wait for 1 second, go to rising, wait for 1 second, go back to idle. We're going to use a delay task and then a transition. So in idle, we're printing our debug text. Yep, the plus button for task. We're going to do a delay task, which will run for a certain amount of time when we hit the state. 1 second, we'll just leave it at default. Once it runs for 1 second, it's going to mark this task completed, which then will let us transition. We can actually transition in a lot of other ways, but that's a very simple and quick way to transition at first. So we're going to run our delay task for 1 second, hit the plus button, and you see the default on state completed. So anytime any one of your tasks inside of your state completes, it's going to mark on state completed and allow you to run a transition. So on state completed, we want to transition to, let's move from idle to syncing. So we're on idle. You can see it updated our little graph over here, which is really nice. Transition to syncing when we complete our state, when our delay happens. So do the same thing, go to syncing, add another task. We're going to delay for 1 second, then transition, hit the plus button, transition to rising, and then one more, go to rising, hit the plus button, add our delay task, 1 second, transition to idle. Now, another thing we could do is we could go back up to root, which would then, fall into idle anyways, which we'll set that up later. Compile, save, let's go back, and we're going to test it out. This should just loop between our states in 1 second increments. So you can see it's going from idle to syncing to rising to idle. And that's good because it means that it is cycling through our states.